Hi, welcome. My name is Suji Maniyam, and today I'm going to talk about preparing data for LLM applications. And if you like, you can take a quick picture of this slide. This is a link to the slide deck. It's public, so you can take a picture, take a screen grab. So this way you have the links, and I'm sure these links will be posted as well. Quick background about me. Um, my background is in AI, data engineering, and big data. So I do a lot of training and consulting. And lately, I've been focusing more on the Gen AI side of things. So, and here's my email as well. If you have any questions, comments, feedback, you can shoot me an email anytime. Yeah. So what does this talk about? Right. So imagine you are building an LLM application. So it could be something like, um, you know, you're doing some RAG, and we'll talk about that. Or maybe you're trying to prepare some data for your LLM application. Most likely, you're going to deal with tons of data, right? It could be various formats, like documents, like PDFs, or Word documents, HTML, or even maybe code. You are doing some training with code. So you'll end up having to deal with lots of data. By the way, these images, you'll see most of them are generated by ChatGPT. Pretty cool, right? So kind of using Gen AI to talk about Gen AI. Right? So imagine I have a bunch of documents which I need to prepare for my application. So a lot of the times I have to go through a series of steps to prepare the documents in a nice, neat format. So it could be something like I want to, maybe I have duplicates, so I want to deduplicate them. Let's say I have documents in various formats like PDFs, HTML. I want to maybe convert them into plain text, just so they are easy to process. And when I'm doing this, maybe I want to remove some of the markups like bold letters, like formatting, things like this, because usually we don't need them for our training application. And imagine my document has some sensitive data. Maybe I have a bunch of documents with maybe somebody's credit card number or a phone number. We probably want to remove those before we actually supply them to our application, right? So these are a lot of the common tasks that we deal with. And if you're dealing with code, for example, let's say you're training your application on a bunch of code repos. Maybe you want to figure out what language they are. Are they like C++, Java, Python, right? You want to do that automatically. And if you have any virus, like let's say you're doing some public repos, and who knows, what you're going to get, right? So maybe if you have some code that's malware, you want to detect that and eliminate that from your training data. And also we want to assess the code quality, right? We don't want, just, code fragments with like, just a lot of blank lines and things like that without any code. So these are some of the common tasks you will actually do in code. So whether you're using documents or code, as you can see, there's a series of things you have to do to get them ready for your machine learning applications. And here's the thing, right? Even though these are these data cleanups, not many of us really enjoy it, but we have to do it to get to have good training data. So this is where data prep kit comes in handy, and that's what I'm going to show you today. So imagine data prep kit as like a Swiss Army knife that has all these like tools built in, kind of handy. It's there when you need it, right? And all of these modules are already built in. And it's an open source toolkit, and it's in Python. So you can actually get it running on your laptop right away. And also, it supports a lot of the tasks that we just talked about out of the box. So you don't have to reinvent the wheel. You can just use the modules, and it will save you tons of time. Yeah. And it's designed to handle both documents and code. Whether your data set is documents or a code or a hybrid, it can handle both. And here's a little bit more, a bit of a functionality diagram here. So you can see, we take documents and code. And for example, I talked about a few things here, like, deduplication, right? Trying to figure out which programming language the code is, right? Accessing documents and things like this. So all these features are already built in, right? And more features are being added as well. So like I said, it's a Python library. It's open source, so you can start on your laptop. And if you have a small set of documents, let's say if you have like a few thousand documents, sure, right? Laptop is all we need. But what do you if you have like maybe like millions of documents? Then probably our laptop is not going to suffice. So what we want to do then is like we want to scale this up. And the kit is actually designed to run at scale, as in like in a distributed in a cluster. You can either use Ray, which is a distributed Python framework, or Spark, which is also another distributed framework. So the cool thing is you can start small on your laptop, kind of see how it works for you, and once you're like, okay, yep, now it works for small set of documents. Now we want to scale it up. It's very easy to scale. Right? So, and by the way, this prep kit was used internally, like the IBM LLM models, Granite models. They were trained trained with data that is prepared by the prep kit. So this is not so this is a very proven project that's now open source. So let's look at some of the features, right? Now we kind of talked about some of the functionalities we would need. So let me show you a quick set of features the prep kit can actually give you. And this is the first step you'll probably end up doing, right? So let's say I have a bunch of documents, most common probably being PDF, Word documents, HTMLs. We actually want to process them and extract plain text out of those. And there's an open source module we use. It's called docling. Docling is a very powerful tool. It can parse a lot of document formats. Right, so I just mentioned PDF, HTML documents, right? So it can handle a lot of formats. It can even do things like, if let's say your PDF has like tables, it can extract table data. If your PDF has embedded images, it can extract them too, right? So it's very powerful, and also it can do OCR. OCR basically means like, let's say your PDF has some handwritten remarks or lines. You can read the handwritten text and try to convert them into text. So optical character recognition, right? OCR. So which is pretty capable. And this is what data prep kit uses internally to parse the documents. So this is usually the first step when we do. And then as we're doing this, sometimes your documents have like markup, right? Now I have some color coding, some bold, italic, whatever. Usually I may not need this. So when I'm doing this conversion, when I'm extracting that content out of the documents, I just want a plain text. Right? Because I don't want to deal with formatting and markups, and this toolkit will do it for you automatically. Yeah. So, which is very great. And this we talked about. So let's say I have some documents, some emails, right? Somebody maybe accidentally left their credit card number or a phone number or social security number, right? What we can do is there's a module here that will scan your documents and remove them. All right, so sensitive data. So it can support things like your typical PII. So by the way, when I say PII, that means personally identifiable information. So it could be credit card numbers, social security numbers, right? Even emails, phone numbers, things like this. You can tell it what to look for, and it'll look for it, and then take them out, which is pretty handy, right? The toolkit we use for this is Presidio, which is an open source tool that we use underneath. Yeah. So as you can imagine, so a lot of the tools we use are open source toolkits that are proven in what they do. So that what the data prep kit does is like it brings them all together into a nice, easy to use, format. And let's say I have a bunch of documents that are in different languages, right? You sort of see here, right? I have English, Spanish and Japanese. And when maybe we want to annotate them into the language, what their languages are. The tool can actually do this for you, right? It can read the document and kind of understand and figure out what language they are, and it can sort of tag them and say, yeah, this is English, Spanish, and Japanese, right? Again, we use a open source module called FastText to accomplish this. And code. So let's say we are going from documents to code, and here you see I have a bunch of bunch of code in different languages, right? C++, Java, and Python. Right, again, remember, we want to automatically tag them and figure out what language they are, right? And again, in the toolkit, actually, we'll do this. You can automatically read the code and tag the languages for you, which is pretty handy. So let's say you want to train Java code in a certain way, or you want to train Python code in a certain way, you can do it automatically. And when you're talking about code, so let's say you are training on some publicly available code, like say open source projects, some public code from GitHub, what have you. You have no idea what kind of code you're going to get. Sometimes the code may have some sort of malware embedded, right, intentionally or unintentionally, and we actually want to detect that and maybe eliminate them from our training data, right? And so actually we use ClamAV, right, which is pretty popular open source toolkit underneath. So as you can see, right, so every feature we are kind of showing you, we probably either have a feature implemented or using like an well-known open source tool. And by the way, the toolkit is is fully open source, right? Somebody just asked me that. Yeah, it's 100% open source Apache 2 license. Yeah. So what I like to do, so I like to sort of do like a little give you like a little demo as well as we are going through this, and you can do this along with me if you like. You don't need any setup. What we can do is we can basically run the code on Google Colab, and I'll sort of explain how the code looks and walk you through the code as well. So this way, you actually see it in action as well, not just looking at a bunch of slides. The use case I'm going to demonstrate is basically let's say I have a bunch of PDF documents, and I want to prepare them for my application. So my application could be something like RAG. So RAG basically meaning we want to supply our PDF documents to an LLM, like things like ChatGPT, right? And ask questions. So let's say I have a bunch of PDFs from my internal company. I want to supply them, and then say ask questions. Things like it could be like, what was the sales revenue on 2020, something like that, right? So again, so in order for us to do this, we need to actually process the PDF documents, right, and take them to a format we can actually supply easily to any LLM, right, ChatGPT or something you run locally. So what we are going to show you is I'm going to show you how to process PDFs, how to do some, figure out, if you have duplicate data and removing them, and also looking at some of the document quality. Yeah. So, and here's the link. So here's the workflow, right? So what I'm doing is I'm actually starting with a bunch of documents, right? And as you can see, we are doing like a pipeline of step by step. So yeah, so don't worry about the whole pipeline right now. I would explain step by step what we are trying to achieve, but this is basically the workflow. And so I'm starting with a bunch of PDF documents. I'm going through a set of steps to basically get them ready for my application. That's it. Yeah. So let me show you where the code is. I'll leave this up here for a second if you want to take a picture or a screenshot. The code is on GitHub. I'm going to walk you through this in a second. And like I said, this particular example, we can run without any setup. We don't have to do any local setup. It's designed to run on Google Colab, right? If you have Google Colab, if you use it before, it's very easy, right? Just click and run, right? That's it. So yeah. So go ahead and, if you can, go ahead and come to this URL, right? It's basically bit.ly DPK workshop. Yeah. Workshop 2 actually. Yeah. So if you can, please go ahead and come to this URL, or you can scan the QR code as well. Same thing. I'll leave this up for a second. Yeah. And I'm going to put this on the comments section, so you can easily click on this. All right. So if you click on this link, you'll come to this page. It's a little larger so you can read the text, right? And this page is what it's like a placeholder. It has links to everything we are going to be using. And I also have let's say you want to set up your local laptop to run some of this code. Here's instruction on how you would do that, right? So again, just to be sure, we don't need to do this right now. But if you want to run some other code after the workshop, you can follow the instructions. And if you have any questions, we actually set up a Discord server with the channel for Data Prep Kit. because we don't want you just just show your demo and just leave you, right? We actually want you to get involved. And if you're trying to use the toolkit, if you have questions, comments, feedback for us, please use the Discord link right here, right, to log in. Yeah. So, and the main code for this, again, like I said, right? I mean, again, how did I get to this page? Very quickly, right? It's in the slides. You can just type in this link, bit.ly dpk-workshop2, right? You can type it in or scan the QR code. Take a picture of this if you need to. Like I said, everything we need is on that page, right? It's on GitHub, yeah, including the presentation. So this is probably the only link you guys need. All right. So yeah, and here's the main repo for the for our repo. So you can look at this. Let me actually go here. All right. All right. So you can see it's Apache 2 license. It's under heavy active development. You can see right now, we are always pushing new features and bug fixes in, right? Yeah. So it's completely open on GitHub. And I also have a private repo that I have some extra examples. So I also gave a link to this if you're interested. So you can check that out as well. So here's what we are going to do today in the workshop. So again, this is kind of a hybrid talk / workshop. I'm going to show you a live demo, and hopefully, if you can also do this along with me. So here's the link to the presentation you're looking at right now. So it's all there, right? So, and also the code we are going to look at is right here. Yeah. So what you can do, if you have a Google Colab set up, you can actually open this link in Google Colab. So usually what I do, I sort of right click on this one and I say open a new tab. Yeah. So see, go ahead and open this if you can. Otherwise, you can just look at my screen, right? So you can absolutely watch my screen here, and I will walk you through the code. But if you can, if you want to sort of give it a try yourself, please feel free to do so, right? Again, very simple, right? Click on this link, right? New tab, and this will open Google Colab, and I have it running here, I think. Yeah. All right, let me see. Yeah, let me make sure mine is running. Yeah. And once you open your document in Google Colab, here's what you can do, right? Again, if you're going to be, otherwise you can just watch my screen, but if you want to sort of follow along, you can do this. You can simply say, again, so I remember, right? I open this on my Google Colab, simply right click, open a new tab, right? So it opens a link like this. Then all I'm going to simply do, I want to simply say runtime, run all. That's all you have to do, nothing else. Right. So I'm going to give you guys a minute just to kind of, right, if you want to run the code yourself, please do that, because I always encourage participants to do more hands-on as well. So, right. So once the code is open on Google Colab, and by the way, somebody just asked me, yes, this is this runtime is free, right? You can use it easily, and you can just say run all. And that's it, right? So I already did run here, and I'm going to walk you through the results in a second. Let me take a moment here and see if you have any questions. Right, so a couple of questions I will go through. So the data prep kit, so we actually have a lot of features. Let me actually go back here, right? I'll put this up here. I'll talk about this. So there are a lot of features that the data prep kit originally implements. And in some of the features, we actually also use our open source tools, right? So rather than reinventing the wheels, if there are a popular open source tool that is actually very good at doing something we are trying to do, we will use that, right? But there are certain things we actually have implemented on our own, like in a lot of the modules you will see, they are implemented from the ground up. So it's a hybrid. So it's not just we are wrapping other open source tools. We are doing plenty of our own built-in functionality, but some of them are open source tools. For example, right, the antivirus detection, right? ClamAV is pretty good at this. They have a long history of doing this, and it's open source, so there's no need for us to reinvent the wheel. So we use that, right? Because we leverage other open source tools in the ecosystem. But what you get is like, because if you're going to use like different open source tools, you kind of have to learn the API, right, and see how to use them. With the data prep kit, the API is exactly the same, right? There we have very consistent API across all the modules, so you can just right, you can just use a very familiar API, and we will take care of translating that into whatever underlying tool is, right? If it's our implementation or an open source implementation, we take care of that. So yeah, so it gives you like a pretty familiar API. So this way you're not like learning like 17 different open source tools independently, right? You're using like one kit, one API, and it does the work for you. Yeah, that's a great question. Thanks for asking. Oh yeah. So another thing I had was, do we have to set up our local environment? So I have like two answers. Right? For the demo, you don't have to. You can run everything on Colab. Right? Easy to run. Right? And I use it all the time. It's free. Right? You can just and you can they support a lot of Python notebook format. That's great. But if you're going to be developing, if you're going to be using data prep it on your own, then I would highly recommend you set up a local environment, right? And then instructions for that are here, right? So, anyway, right? So just to be clear, we don't need this right now. But if you're going to be, experimenting, kind of playing around with the toolkit, I highly recommend you guys set this up. All right. So let's keep going, right? So hopefully you guys have the code running. I'm going to show you step by step what's happening and how we are setting up this, right? How we are using the code. So this will give you an idea, right? You can see it in action. And guys, please feel free to ask questions. I will keep an eye on the chat window, and I will try my best to answer the questions. Yeah. So yeah. So there's no such thing as something too simple, right? Please ask away. I'm happy to answer them. All right. So let me go back here. So we are at this point, right? We have got this, right? So you open the notebook, you say run all, right? So this way it's kind of running, and then we can walk through the results, because there are some steps that will take like a minute. Like for example, when you're installing some dependencies, that may take a couple of minutes. So we don't want you just waiting there, right? So just say, that's why I recommend you guys to run all, and then we'll walk through it. So okay. So let me walk through the code. And so here are the steps we are walking by, and don't worry, I will explain them step by step. And remember, I said this notebook is designed to run locally on Google Colab. So there's no changes required. The same code runs in both places. And here's like a little check I use to figure out what environment I'm running on. Right? Because if I'm running on Colab, for example, right? So here, if I'm running on Colab, I need to install my packages. And I don't need to do this when I'm running locally, because why? I would have set up my local environment already. So there's no need to keep reinstalling it, right? So that's why these checks are pretty handy. So if I'm only doing this if I'm running on Colab. And this step you may have taken like, see, to me, like this step took like 4 minutes. Yeah. So so that's why I recommended you guys sort of start the run, because we don't want to just sit there for 4 minutes, right, looking at it. So mine is done. You can see, see the check mark, mine is done. And sometimes when you install new packages in Colab, remember you're running a file, it's installing new packages. Sometimes they will ask you to restart the runtime. Right? You can, right? The reason they suggest this is like, just so they can load libraries, the newly installed libraries, without any issues. But most of the time, it'll just work fine. But you can also choose to restart it, right? So if you choose to, so either way is fine. And so again, I have the steps outlined here, so I can talk about them very quickly, right? And all we are doing here is like, I'm just setting up input-output directories. And remember, right, our pipeline goes like this, right? So we have multi-stage pipeline. So when I execute, say, stage 1 is reading my input directory, input files, and then producing the output into a temporary directory or an intermediate directory, and that output becomes the input to the next stage. So imagine like a pipeline, right? So every stage is reading some input, producing some output, and that output is then input to the next stage, and so on and so forth, right? So and that's why you see like a series of steps, because a lot of these transformations or the workflows, they process the data that was generated by the previous step, and that's why, right? So all we are doing right now, right? So just remember, we are setting up like a pipeline. So step 1, I'm extracting the text out, right? And step 2, I'm doing, right? Step 3, and so on and so forth. So this way, when you look at the output, you will see how the data is being transformed. That's it. Yeah. And here I have a couple of utils file, like, because we use a Parquet format internally to store intermediate data. If you're wondering why Parquet, because Parquet is a very efficient format to store data, right? It's very compact, it's very fast. So whenever we produce temporary data or intermediate data, we use Parquet, right? Because as you can imagine, there are, right, I had to go through a few steps, right? I started with the input here, and here's my output. But there's a bunch of intermediate data we have to create and process for us to get there, right? And the intermediate formats are in Parquet format because it's an efficient format to store data. Yeah. So, all right. So let me show you. And again, so the step 2.3 is, I have some handed utilities to read some Parquet files, right, and download files if you want to. That's it. Yeah. So step 3, let's look at the data here. So the data, this actually I'm using very small file just to illustrate the concept, so you can understand what's happening in our data. So I created a couple of files, earth.pdf and master.pdf, right? And I also have some duplicate data, just to illustrate what the tool can do for you. So earth.pdf, just like a one pager about some basic, right? Facts about Earth. And then we have master.pdf again, right? One pager, right? Again, remember, these are simple documents. And then I have a copy of earth.pdf, exact copy, right? Just to simulate duplicate data. And I also have earth2.pdf, which is very similar to earth.pdf, except like 1 or 2 words difference, right? And these are what I call near similar documents. Because remember, a lot of the time, imagine you have a document, right? Maybe you entered a couple of, you create a copy of the document. You didn't really change much. Maybe you entered like a couple of new lines, right? So if you're doing like an exact comparison, they will look like 2 different documents because, there are a couple of extra blank lines in the new document, but it's not really adding any new information, right? So we want to eliminate them too, right? So when you're eliminating documents, if I have a document, 2 documents, and the only difference is just blank lines, right? I want to eliminate those. Right? Anyway, so to demonstrate this, I have earth2.pdf. Again, you can click on these links, right? And then you can inspect the PDFs. They're just very simple one-page documents. And I also have like a spam, right? Just to simulate, if you have like, let's say you have some document which is, just a bunch of spammy words, right? And the final one is lorem ipsum, right? So this is basically, right? Let's say you are doing some design work, putting some placeholder text. Lorem ipsum is like this popular placeholder. And what happens is sometimes, let's say you sort of started creating a document, you put some placeholder text, but you didn't really add any other text. This is probably not very useful because all you have is like a template with just a bunch of placeholder text. That's not very useful. And so we can eliminate them too, right? I'll show you how. So as you can imagine, we are starting with like a series of documents. So I created them, right, just to illustrate certain features I'm going to demonstrate. Now, very good. And so we are downloading some data. Remember, when you're running on, when you're running on this in the cloud system, they don't have the files. So we're downloading the files locally, right? That's it. And that's what this step is. And you can see, right, it's downloading the files here. Yeah. So, yeah. So first step 4 is we are going to start the processing. So everything so far is like a setup, right? We install the Python packages, we download the data, right? All that is done. We set up our output input directories. Now we are going to start processing the data. So let me show you. So you will see me I'll sort of switch back and forth between the presentation and the code, just so you can understand, right? So yeah. So here what I have, right? The first step I'm going to do is I have a bunch of PDF files, as we just saw. We are going to basically extract the text. Right? That's the very first step. And if you look at the PDF file names, they are done purposefully. For example, right, you can see I call this file A, B, A dash. So A dash and A are very similar, right? Maybe like only 1 or 2 words are different, right? So this B and this B are exact duplicates, right? So duplicate documents, right? And then another file called C. And sort of look at this file name so you can track their progress as we go through this pipeline. Yeah. So first step I'm going to do, I'm going to basically extract the text data out of the PDF. That's it. So let me show you how this is done. So if you look at the code, it's basically step 4.1. And like I said, we are using a dockling a model underneath to extract data from PDF. Dockling is a very powerful utility that can pass a lot of different formats. You can support PDFs, HTMLs, right, Word documents, right, things like that. So here we are doing only PDF. Yeah. So all I'm doing is, right, I'm basically running this module. It's called PDF to Parquet, and all it does, right, it looks at the PDF files and extract the text out of them. That's it, right? And I'm extracting the text in markdown format. So all I want is, like, given a PDF, I just want simple text, but I still want to retain some of the formats, like headings, tables, things like that, and bullet points, right? And markdown is a really good way of doing that. So that's what I'm doing, right? So I can say it like a one-liner, right? That's pretty much it. Right? I'm supplying my input directory, output directory. I'm asking you to only look at PDF files. So for example, if you have a directory with like mixed files and you only want to focus on PDFs, there you go, right? And then I'm saying, generate the output, extract the text in markdown format. So markdown is text, but still kind of maintaining some basic formatting, right? Which is great. Yeah. So while you're running this, you may have noticed this like a progress bars. So what's happening is, remember, we're actually using an open source model to look at the PDFs and extract the text. So it's actually downloading the model on the fly. You can see, right? It's initializing model, it's just downloading it, right? So the first time you run this, it may take some time because they have to download the model and then initialize it, right? But once it's done, right, you'll basically say, yep, it's done, right? So all we have at this point, what we have, you can see, sort of see here, and this 4.2, what it's showing is it's actually displaying the data that we just parsed. And what you will find, if you look at it, let me actually do it here, right? See how the data is being created. So it displayed it in table format, so it's easy to understand. So you can see every file we actually supplied has an entry. So master.pdf, spam.pdf, right, lorem ipsum. And here's the content. If you look at the content column, you can kind of see the contents, right, that's extracted. And also you can see, right, for example, master.pdf, you can see this is the markdown format, all right? And also you can see, we only have one pages, and then, there's no tables present, and also like some of the other attributes creating, like it creates like a hash of the documents, right, and things like this. So in this very step, while extracting data from PDF files, it's also, getting you all the metadata, right? How many pages, what are tables, and things like that, right? Pretty good. Yeah. Oh yeah, so a couple of questions on this. Actually, let me talk this and I'll just show you a question, right? So 4.3, I'm explaining what are the columns you are seeing, right? For example, the hashes are created, right? So we can actually track if they are similar documents or not, right? Just like you would. And we use the hash function, computed hash values to eliminate duplicates. Yeah. All right. So here's some contents, right? So here I'm just putting some content out. So this is like, I think it's going to print out mass. So you can see, right? So this is basically my PDF document extracted as text. And that's it. I can see just a couple of paragraphs. Again, remember, I am keeping this very simple so we can understand the formatting. Yeah? And that's mass. And I have like a spam document, right? Just some spammy words and so on and so forth. So this is step 4. So I hope we kind of understand, right, how this step is executed and the output. Remember, we are basically at this very first step. Yeah. So I have a few questions here. I'm going to take a second to look at the questions and answer them. Let me see here. Yeah, we talked about open source versus internal implementation. Yeah, right. So remember, the toolkit itself is open source, but if there are some other open source tools we can leverage, we use them, right? For example, in this case, we use dockling, right, to process PDFs. Yeah. So yeah, so there was a question about the runtime, right? I mean, I've been using Google Colab, so that's why I'm showing it here because a lot of people use that. But you can run some any other runtime, GitHub's, IBM, right? Yeah, any environment that supports Jupyter notebooks, you can run on this one. Yeah. So yeah, so you have no issue at all. Oh yeah, so there's a question about embedding. So for example, if you may have noticed this, that's a great question about GPU, right? Oh yeah, right. Remember, you may have seen this little warning here. it'll say this module is much faster with GPU. So remember, even when we're extracting PDF, we're actually using an open source model. It's actually a deep learning model, right? And as you know, these models run much faster on GPU. Now, if you had a GPU on your system, it'll automatically detect that and use it. Pretty cool, right? And Google Colab, you can actually get a GPU if you want, right? You can change the runtime to include GPU. So if you detect GPU, it'll automatically use the GPU for you, right? Now, just to be clear, you don't need a GPU, right? But if you have it, this will run much faster. Yeah. So GPU detection is done automatically. And we use the typical, we use PyTorch, right? That's where the package run. So the PyTorch actually will execute the compute on a CPU or GPU or even both, right? Yeah. So depending on your setup, exactly. That's a great question. Thanks for asking. Yeah. So GPU will definitely help you. And actually, the machine I'm actually demonstrating right now, I have a local workstation. I do have a GPU, right? Because I do a lot of this work. Yeah. Great question. Yeah. The links to the notebook. Yeah. So again, I just want to put this up, right? So all the links you guys need right here, guys, is this, right? Maybe you can sort of take a picture of this. I mean, yeah, there we go, right? Yeah. So this is it, right? So this is the link that has links to everything, all the code, presentation, right? And every other resource we have. Let me put this link right here on the chat window, right? Just so you guys have it. Yeah. So this is the only link you guys need. Everything is here. So maybe you can take a picture, right? Take a screenshot, whatever. Yeah, exactly. And this is all on GitHub. Oh yeah. So actually, there's a question from Mohammed. I'll get back to that about document detection. Yes, the metadata we supply. By the way, right, when I run this code, by the way, these are really great questions, guys. Thanks for asking, and I really appreciate this. I will also try to keep it moving, and also if you want to ask me a little later after the presentation, I'm happy to hang back and answer questions. So this module has tons of other parameters. I'm showing you some of the basic ones here. If you ever need to know more, right, all you have to do is look at the documentation. Right? There are so many things you can configure. For example, you can say something like, ignore images. Don't worry about images. Or you can say, do not extract table data, right? Or so you can configure this, in a lot of ways. So here I'm just showing you some of the basic config, right? So if you have every module I'm using, there'll be a link to this for the documentation. So that's what you should consult. Yeah, very good. Okay, so next step, right? So let's keep moving. So we extract the text from PDFs. So we have plain text, markdown text, which is great. Next step, this is something we do internally. What we do is called calculating document ID. So what we do is we compute the hash for each document. The reason we do this is we can eliminate duplicates easily, right? So every content that we extracted, we're going to compute a hash, right? So this step is required for the subsequent the dedupe steps. So we do this, right? And let me show you in the code. It's very simple, right? Step 5, you will see here. Let me scroll down a bit. So step 5, create document ID, right? All it's doing is is creating a unique ID for each document, so we can track them, right, and through the pipeline, and also we compute things like hashes, yeah. And right, as you can imagine, there's right. Basically, I'm saying, right, I'm saying calculate the hash in the contents column. Remember, when we extract the text, where is it stored? If you look at the value above, right, it's stored in the content column. So that's what I want to focus on, because things like file name, right, data modification, they are not very reliable, right? What is reliable is actual content, because that's what I care about, right? What the content of the file is. So we are saying compute the hash on the content. Yeah. So that's what this is doing. Again, you can change any of this at any time, right? So here, if you want to change a column, you want to compute the hash on, feel free to do so. But most likely you would want contents. Yeah. And it's doing this, so it's computing the hash. And if you look at the output, right, again, 5.2, if you look at the output, let me show you right here. You scroll to the right, right, see how the hash and this is integer IDs, so just an ID we create internally to track the documents and the hash. By the way, right, some of you may have noticed this already. Look at these two hashes. They are identical, right? and look at the file, file name, earth.pdf, earthcopy.pdf. So immediately you should say, aha, right? We are ready to remove duplicates, right? Because my hashes are matching here, right? And that's exactly what the next step is going to be. Right? And this is where we compute the hash, yeah? Because the file name could be different, right? So file name is not reliable, but I really want the actual content. If the content is exactly the same, we are going to remove the duplicates, yeah? And that's the next step. Yeah? So let me switch the presentation real quick, right? So next step is going to remove duplicate. Now here I'm going to show you two duplicate removal. One is exact duplicate, meaning the files are exact copies. And here you already know the answer, right? Because what we are going to do, we are going to simply compare the hash we just computed. And you can see, right, this hash is the same. So next step, I'm going to basically say, hey, and you'll see this right here, right? I'm saying, look at this hash, and if they're exactly the same, only keep one, right? Pretty straightforward, right? And also, right, we are reading from the previous, remember, right? This also gets like a pipeline. I'm saying, look at the document text, and then just look at the hash values, and if they're the same, only keep one. Yeah, there you go. So once I'm done this, again, I run the step, then I print out the output. You will see I started with 6 documents, right? And after the exact dedupe is done, I have only 5 left, meaning 1 document is eliminated. Which one did we lose, right? Which one did we filter out? Let me see. Okay, yeah. So remember, right? So Earth, remember there was like Earth and Earth copy, if you remember, right? So it's now we are keeping Earth copy. Doesn't matter which one we keep, right? Because they're identical. So so Earth.pdf is filtered out because why? Because the hashes were exactly the same. Now this is pretty cool, right? Imagine you have like millions of documents, right? And trust me, you're going to have a few percentage of documents that are duplicates, and you want to eliminate them, right? Because you don't want to carry them through the pipeline and right for your application, because that's just duplicate data. So here you see, right? Basically, in like a literally like like a 1 line of code, basically, you're removing all the duplicate documents. Yeah, pretty good. So here the comparison mechanism is pretty simple, right? We are comparing the hash, exact files, exact matches are removed. But here's a cool thing, right? Next one is called fuzzy duplicate. So imagine, let me show you what this is, right? This is the next step, right? This is the next step I'm showing you, right? Next step. Let me show you, right? So here, just to kind of illustrate the concept. So let's say I have documents here, just simplicity. So I have A and A, they are exact matches, right? Duplicate, and they're the exact same text. And when I run the dedupe, what's going to happen? I'm going to remove 1A. Doesn't matter which one, right? Just one of the A is gone. Yeah. Now, the fuzzy dedupe is a little smarter, because now imagine I have 2 documents that are almost similar, right? So I kind of put this like some sample text. So imagine one document has this, another document has like maybe like an extra word, or maybe like an extra blank line, right? So that's why they're not exactly the similar, but pretty much similar for our purposes. And we want to remove them too, right? Because for our purposes, they're the same. We don't need to keep them both. And this is where the fuzzy dedupe comes in. Actually, this is a pretty cool feature. This is one of my favorite features here on the data prep kit. So when I run the fuzzy dedupe, it can look at the documents. It can remove near duplicates, which is pretty cool. All right. So let me show you how this is done. Right. So remember, I started with 4 documents, 2 exactly the same. Right. One is right, near duplicates. So I do the exact duplicate removal. So like one of the A is gone. Then B and B dash are processed through fuzzy dedupe, and we're only keeping 1. Right? So then I end up with 2 documents, A and B. Pretty cool, right? So let me show you the code real quick. By the way, right, again, all this code is here for you guys, right? So I'm walking you through so you can see it, right, in action, right? So here's my fuzzy dedupe. Again, fuzzy dedupe takes a lot of parameters. It's very configurable. One of the parameters I want to show you is called the threshold. So remember, when you do fuzzy dedupe matching, like you can control how aggressive you want it to be or how lenient you want it to be. And the dial here is called threshold. So threshold is between 0 and 1. So we crank it all the way higher, you are doing very strict checking. If you dial it down a little bit lower, so now you're a little bit more flexible, right? As in like, so more documents will match because, right, your matching criteria is a little lenient. But if you crank it higher towards 1, now you're doing very strict checking. So fewer documents will match in a fuzzy match. It's completely up to you what setting you guys use. And a lot of the time, one of the question I always get is, what's the recommended value? Let me tell you this right now. There's no recommended value. The default value is 0.8, right? But that may or may not work for your document. So you need to play with this dial a little bit. Sometimes you want to tweak it a little more, maybe dial it down a bit to see what works for your document set, right? So there's no like a recommended value. We start with 0.8, but that's why I sort of highlighted here. So this is, think of like a little dial, like think like a volume button on your on your stereo, right? You want to like dial up and down to find the right volume for you. Yeah. So that's why I have it here. Right? Let me run through this, and I know I have a couple of questions. I will get back to them in a second. So when I do the fuzzy dedupe, again, right? I mean, remember just one liner. I just split them into like a bunch of lines. So each each parameter is obvious. So run through this, right? Let me print out the output. See, I start up with 5. I'm ending up with 4, right? So let's see which file we lost. So I see Mars, spam, lorem ipsum, earth. See, remember now earth. Remember they were like earth copy and earth number 2, right? So now earth number 2 is eliminated. Because why? It's not exact match, but it's a near match. So this is pretty good, right? So now my fuzzy dedupe actually eliminated 1 document from the testing set. Pretty good, huh? So, all right, let me take a second here. Let me look at the comments real quick. Hash. So the hash we are computing, right? So hash function is like a, so imagine your content. Let's say I have like a 100-page PDF, 100 pages, right? A hash is basically you can take the 100-page text and create a hash that looks like basically this, like a, maybe like a whatever, say 20, 30 characters. And if your document contents any different, you get a different hash. So the reason we compute the hash is hashes are they are very quick to compute and very easy to compare. So imagine I'm comparing a 100-page document with another 100-page document. If I did character by character comparison, it's very expensive, right? But if I compute the hash, remember, right? Because hashes are very unique, right? So each document will get its own hash. So the hashes you only get the same hash twice. Let me go back up here so you can show you. There we go, right? Even further up. There you go, right? So here the hashes are exactly the same. You see that, right? Because the content is identical. So now, so imagine these documents are 100 pages each. So now comparing 100 pages, side by side, I can quickly compare the hashes much quicker, right? So yeah, so hashes are mathematically guaranteed to be unique. If your content is unique, you get the same hash. Yeah. So the content are identical, right? If you compute the hash, mathematically they are guaranteed to have the exact same hash, and that's why you see, right? The hash is exactly the same, and it's much easier to compare the hash. Pretty good, right? Anyway, so we use hashing extensively in data prep to compare documents. Even fuzzy dedupe is using the hash, right? But you will say, wait, the fuzzy dedupe, right? It doesn't, right? The hashes are not the same, right? So how is it actually doing it? So what fuzzy dedupe does is like it takes the hashes, it compares the distance. So let's say one hash is here, another hash is here, right? And fuzzy dedupe will look at the distance and say if they're like very close to each other, maybe they are the same documents. If they're farther apart, right? Maybe they are not the same. This distance is what you control, right? So when you tweak this knob, you're kind of telling it, right, how close the document hashes should be to, right, to be considered a similar document. Anyway, you can read about this. I mean, right, I'll put a link to the documentation. They have an extensive document, how they identify fuzzy matches. Yeah, you can read about that. But basically, right, you can start with this this little knob, and then tweak it to fit your needs. Cool. All right, last step, right? So where are we in the overall scheme of things, right? So we did the deduping, right? So final step is document quality. So let me run through this real quick, then I'll get back to Q&A. Yeah. So we run through this. So I started with a bunch of documents, right? I eliminated duplicates, even the fuzzy ones. But I also have to want to do one work that is basically, let's say my document has a bunch of spammy content, right? So let's say, right? So document C, just spam. We all have emails, right? Spam emails, right? Some of the emails are just, spam, right? We don't want to consider them. And then another one, let's say placeholder. It only text as lorem ipsum. So it has no real data, just, a bunch of placeholder text. Now, what I want to do, I'm going to eliminate these two. So how do I do this? So there's a plugin called document quality. It'll go through the document and it'll scan the documents to figure out, is it spam? Is it just a placeholder text, right? And then based on this, I'm going to eliminate this. Right? Let me show you how this looks in the code. All right. So we are right now at the step of, where are we? Step 8, right? Almost the last step. And this plugin is called document quality. So very simple, right? So you simply see the document quality, just tell, which contents to examine, right? Because remember, content is our, column name where it actually has the content of the file. So I'm going to say, hey, scan the contents. And here you can control the language, right? And here you can tweak the language. You can also supply multiple languages if you want, right? But here I'm just restricting to English just to keep it simple, right? And here, somebody asked me, how do I control the language? This is how, yeah? So, and that's it. So at the end, right, if you look at the output is generated. So let me show you this real quick. Look at the headers, right? Look at the column names. So you guys already remember, like, we had all these things before. Now, after you run document quality, you have a bunch of new columns that start with .q. And these are various metrics they actually calculate for you. Let me show you a couple, right? That's interest to us, right? So they're like, how many sentences you have, right? Oh, look at this. See, this is interesting to us. Lorem ipsum. Meaning they're saying, hey, do you have a bunch of placeholder text? And you can see most of the documents have 0, right? Except one document has some lorem, it's the lorem ipsum text is detected. And, and so not surprisingly, it's going to be, right, our lorem text. So as you can see, what it's doing is creating a matrix, all right? And there are a lot of other metrics they calculate. Let me show you another one, right? Does it have a bad word, right? So things like spam words, right? Right? It'll flag them. So you can see one document has bad word, and not surprisingly, what is it? It's my spam.pdf, and this is my bad word, right? So, and by the way, you can control, right? So right now it actually has a built-in dictionary of bad words it tries to detect. You can supply your own. Yeah, and then actually I have a link right here, right? There's a bad word file up here, right? So there are bad word collection. We actually use a built-in one, but if you have your own, just apply it. It'll match, bad words from your dictionary. Very customizable, right? Anyway, so what I'm going to do, right? So you can see the metrics already created, which is great, right? So it's already creating metrics like, right? For example, right? Does it have common English words, right? Does it have bad words, right? Does it have lorem ipsum? Things like this. So to me, I'm going to filter out some of these documents, with some of the flags. So for example, I'm saying, look, if a document has bad word, right, I don't want it. So I'm saying only extract the documents where the bad word flag is set to false. Yeah. And I'm also saying only extract the documents that doesn't have any lorem ipsum text, meaning, I want 0 lorem ipsum, right? And again, this is a parameter you can tweak, right? And at the end, right, I am left with just these 2 documents. Interesting, right? So remember, I started with like what, 6 or so documents, right? So we went through the whole process of removing duplicates, removing fuzzy duplicates, and now we are removing like low quality content like spam, lorem ipsum, things like that, right? And we are ending up with actual good document set, right, for our application, which is pretty good, right? And then let me show you the final output. I think this will work. There you go. Look at the output directory. If you click on this link here, it will show you the output directory, right? And you can see, right? So you can see my workflow, right? You can sort of see here, right? I'm starting with 0, 1. If you expand it, you can see a little bit more, right? So, I started with a bunch of documents here, right, with the file names. And every step I go through, right, exact dedupe, right, so on and so forth. And the final step, if you look at the documents, I only have 2 documents, right? I have one Earth, one Mars, right? Let me see if I can open this. There you go, right? That's my Earth, right? Markdown, and that's my Mars Markdown. Remember, they were originally PDFs. We extract them into Markdown format, right? It cleared out all the formatting, right? Now clean Markdown text. Pretty good, huh? So this is hopefully, hopefully gave you an idea of what's possible, right? So we started with a bunch of documents. Let me get back to the slides here, all right? So this whole pipeline we went through, right? And then we ended up with 2 good quality documents. Now, if you look at the code, right? I mean, sometimes people look at the code and say, right? I actually have this code, right? Remember, right? I am actually having a lot of comments and things like this. But if you just want to write the code, right? Just, each module is like, just 2 or 3 lines. That's it. All right. Here I added like a lot of debugging information so you can see how the progress is going. But if you just want to use it, right? Each module you can just use like in like 3 to 5 lines of code, which is great. Yeah. So, all right, guys. So final summary. Let me see how we are doing on time. Okay, perfect. We have 5 minutes left. Yep. So please take a look. You've seen it in action. You see how easy it is to use, and hopefully your interest is piqued by seeing some of the features. So here, right, I actually showcased a couple of features. We showed text extraction. I shown you so when I do text extraction, I'm also doing cleanup, right? Dedupe, we just looked at 2 dedupes, right? Exact matches and also fuzzy matches, which is very cool. And we also looked at document detection, right? So document quality. So it can look at things like spam words and placeholder text and things like this. And there are many more modules, right? So it's a pretty versatile toolkit. You can very rich functionality. So please give it a try, right? And also you can always chat with us on Discord if you have questions, comments, and we are there to answer it. So let me do this real quick. Let me put up the slide. So this is right. So here, actually, let me do this. Let me go to the very first slide so it has all the links. All right. Let me look at some of the questions, and then we'll wrap it up. Oh yeah, there we go. Slides already there. Right. Perfect. Yep. Oh, so the question is, how much PDF can it process? Great question. Remember, this toolkit you can run on your laptop. So if you're like a few thousand or so, I would say run on your laptop. That's fine. But if you're like hundreds of thousands or a few million, right, then we will definitely recommend running as a cluster mode. So the latest data I have on this one is terabytes of data has been processed by this toolkit. So right, of course, we are running on a cluster, right, on a cluster of maybe like about 50 to 100 machines, right, when you have terabytes of data. But yeah, it can. So it's been proven at scale when training the IBM Granite model. Yeah. So this is not some toy project, right? This is actually very well proven in the field. It can handle huge quantity of data. So that's why we always say start on your laptop, kind of see how it goes, and then you can always go from a laptop to a cluster very quickly. You can either use Ray, Python Ray framework, or Python Spark framework. So you can, right, and it can scale on both. Yeah, exactly. Great question. Yeah. Oh yeah. So another question about sensitive data, right? So this is very good. So let me actually do this real quick. So one of the modules we have here, right, is called, just remember, you can see the module like PI, document quality. Another module we have is called PII detection, right? So same thing, right? It'll look at your, scan your document content, and you can show it to like redact personal information. And it's very easy. You look at the documentation. We have an example there you can use. You can specify what kind of information you're looking for, like phone numbers, social security, credit cards, right? And it will basically go and eliminate them all. Yep, absolutely. So it's already built in. Definitely use. Yeah, right. So it's a great question. Okay. And then, another question is like how large the files can be. The files can be fairly large. It's basically capped by how much your machine can handle, right? I know, like, people have processed, like, hundreds of megabytes of files, file sizes, but it'll take longer, obviously, right? The file is kind of large. It's going to take a long time, but yeah, it can handle the file sizes, no problem. Yeah. Oh yeah, right. So we talked about the fuzzy dedupe, how it removes. So it's basically, remember, right? It's not an exact hash match. So it's looking at hashes, but remember, it's now hashes are like in two different spots, right? Because they're not exact. So it's trying to compute the distance between them. And if they're like too close to each other, it's saying, yeah, they're pretty much the same. If they're too far apart, then they're not, right? This distance you can control, right? So that's what the parameter does for you. So if you say, right, if you tweak the parameter, even documents kind of farther apart will be considered same. But if you kind of make it stricter, then the documents have to be very close to each other to be considered the same. Right? Yeah, that's how you control it. Very good. Yeah. All right, guys, very good. So we are just about on time. So if you have any questions, please send me an email here, right? You can also join our Discord to ask questions. I sincerely hope you guys, you're excited to learn about this. And please use them internally for, if you have any data cleanup, data prep tasks, right? Hopefully it'll save you some time. I look for, and thank you for being here. I really appreciate your time. And hopefully we will see you in some other presentation. Okay, thanks, guys.